Hey gang, Dan here, marginallyclever.com. I want to give you a brief tour of this robot arm, talk about the parts and what they do, and give you a look inside some of these bits so that you understand what's going on, and then we can have more conversations about deeper subjects, deeper conversations about subjects here. I would like to give you a brief tour of this robot arm so that then you have the names for all the things and we can then have discussions about it and get even deeper into the subjects that are interesting. So this is made of 6 actuators and each of them turns. Let's see if I can undo the, oh yeah, there we go. So this is the output of each of the actuators. And this is a lot like a hobby servo. Here's a hobby servo. Right, so this bit turns, and inside here there's a sensor that knows the angle. So I say I want to go to the angle X, and it does it. And you see the horn is replaceable, right? I can unscrew from here and pop this off, and then put something new on there. So, and then also you'll notice that it has these mounting holes on the sides there. And these screws that go all the way through and bite into the plastic top, and that's what holds the whole thing together. There's also a little motor back here and a gearbox under this side, a collection of gears in different sizes that turn a fast-moving motor into a slower but stronger motor. Okay, so here we have the same output and a similar shape, and these screws go right through, and you can see in here there's another screw here. These screws actually go about halfway, and in the middle here, you'll see later, there's a piece that holds them together. Okay, so then there's this connector on the ends, and these are different so that you can mix and match and change them up. Like here, this block is just a straight square piece. Okay, it's almost like a Lego block. And then this is a special base piece that's mounted to this board, which is then clamped down. Okay, so this is the base, and this is the base motor. This is joint 0. Then joint 1, this is the strongest one, the shoulder. J2 at the elbow. J3 is up here. Yes, J3. And finally, J4, the sticker is on this side. Right, so in total, we have 0, 1, 2, 3, 4. That means 5 in total. And if this is a 6th one, that's for, I busted it when I was putting it together, but it should be here instead of this. And then you can rotate this, and it would move this hand. This hand would come over this line, which is nice because then this all stays on a line, and I like that. Okay, so let's look inside one of these jubbos. So here, I would take this top plate off. Let's take a look inside one of these gearboxes. So this is 7 centimeters from one side to the other, and the same thing across. Now in here would be, the motor would go right here, and there's a hole for the wire to go through, and then here's a gearbox. You see, we get them with a special pulley on here, so the motor shaft would come out here. And then this pulley would be here. And this belt goes around both of these. And the rest of these fasteners, here's the mystery piece that I was talking about. So this actually sits back here. And if this one has got it, yes, you can see here, there's a special corner that keeps this from spinning. I'll put this in there. Keeps it from spinning so that you can undo from either side to get into it really, really quick using my handy drill. Hi, here's our motor. So this mounts this away inside here. Okay, good. That was a lot of shaky cam. These mount the gearbox, and that's all there is to it. It's all M3 screws. These have to be M4 because that's the gearbox requirement. And so I make a bunch of these, and then you can 3D print the shell if you like yourself and just get the gearboxes. not much mystery to it. Now this does not have a sensor in it because I mentioned a sensor and you may be asking, where is the sensor? The sensor is coming. You'll notice that through the center here, there's a hole that goes clean through. So you can attach something on this side that goes right through and then put your sensor right here inside, like here. And then that wire can talk, and the circuit board can talk directly to this motor. So that's the plan. And then you can daisy chain these motors, and a wire can come through a tube here that connects to the circuit board, and then the wire from this motor goes out to the next job this way through here and back and so on. And then you can chain them one after the other. So all this exposed wiring, all this dangly bit, that goes away, and there'll just be one wire that comes out the bottom, and it'll be perfecto. So, lastly, I can't forget the brain board. So this is a Roomba board. It drives 6 stepper motors. This is a stop gap until we can have one board inside each actuator. I also have here a 6 amp power supply, 6 amp 12 volt, right? Output, 12 volt, 6 amp. 24 volts might work a little bit better, stronger motor response, but this is acceptable. It runs. The firmware on here is actually Michelangelo firmware from the drawing robot, which is this guy, right? It's yeah, no, you can't see it in this light. But that's the drawing robot. There we go. Doing pictures and stuff. So I developed this robot by learning to make these 2 motors move. And the code is based a lot off of Marlin, which is a 3D printer software that runs in these guys. And you see there's my printer farm. So the Marlin firmware runs all 6, modified Marlin firmware runs all 6 stepper motors at once. And then after that, everything is all a software problem. So I have done some limited movement tests, and I have, as of this second right now, as I film this, they're up on Patreon, a private YouTube link. They'll be available later for everybody else. I don't yet know the limit on how much weight this can carry. It's supposed to be 2 kilos. But we shall see. I'm taking my time with this. A maximum speed right now appears to be 5 degrees per second. And that is a limitation of the low speed of the chip in here and the low torque of the motors. The small motor I put in here there's actually, like if I hold this up, you can see here how much room there is in the top of the case. The motor could be that much longer, and then it would be that much stronger. Also, a DC motor would run much, much faster with more torque, but I don't know enough about DC motors, and I would need a whole new electronic configuration. So if that's your kind of thing, let me know. I'm very curious to talk to the people who know that kind of stuff. I'm getting old. There's only so much time in the day to learn new things. Some of you have taken the time, and I would love to collaborate with you. What else can I tell you that I've missed out on? These plates are kind of fun. A lot of thought has gone into printing so that there is no support material or very little support material. And this particular triangle bracket was a big favorite of mine because the side pieces are one print, and the end pieces, the flat bits that go in here and here, those two, they're separate pieces. And it also means that they're much stronger. They won't split apart along the printing, the layers, right? You can see the layer lines. It won't split on the layer lines. In the boxes, because the screw goes all the way through, and in the corner bracket, because it's made of multiple pieces. So there's no line like this, there is no line like this. And yeah, and the same kind of trick is done down here on the base, so that the sides are separate from the center. Okay, that's been my tour. Thank you for sticking around for all 10 minutes. I've been Dan, marginallyclever.com. Thank you to my patrons, and subscribe for more. I'll see you next time.